PIs. So will this change affect or not affect? So this will not affect optimality. Why it will not affect optimality? It will not affect optimality because it is nowhere concerned with Zj minus Cj. Since it is not concerned with your Zj minus Cj, it will not affect our optimality. So now, where are we concerned with this? We have our xb column. Our xb is nothing but capital B inverse, the matrix inverse of the basis vector into the small b. So here this depends on B. So XB will depend on B. So here occurs the change. So what happens? It will affect the feasibility. So it affects the feasibility. The solution may be basic, but being a feasible solution or not. So it will affect the feasibility of the solution. So this is where it is going to cause a change. If at all it is going to cause into our problem, if we look at it like this and talk in XB terms, B terms, many people may feel irritated, rather out of the box. So let us take a small sum. Maximize Z equal to maximize Z equal to 5x1 plus 12x2 plus I have 4x3 subject to what are the constraints? It's going to be subject to x1 plus 2x2. We are going to have less than equal to 5, 2x2 less than equal to 5 and 5x1 minus x2 plus 2x3 equal to 2. Please make a note, the constraint is having equality and all our xi's are greater than equal to 0. So what we have to do in this problem? First thing, we will solve the LPP. This is our usual mode. Solve the LPP. Then after solving, we have to cause a change. So what change we are going to cause? Solve the LPP. Then secondly, discuss the effect of changing. Discuss the effect of changing the requirement vector. Requirement vector means B. Changing the requirement vector from changing the requirement vector from 5 to 7 to 5 to 7 to on the optimal solution. Okay, on the optimal solution. So this is the change we are going to do, and then we are going to discuss what is going to happen. Right. So now can anybody tell me what will happen to the constraint? What variables I should have? I have maximize, so everything should be less than equal to. Even otherwise, I don't have to touch the objective function. I will have 5x1 plus 12x2 plus 4x3 subject to. What is the first one? You will have x1, you will have plus 2x2. It is less than equal to, so what variable should I add?
Slack.
Yes, so let me add my slack variable s1 equal to 5. The cost associated with the slack is 0, so objective becomes 0 s1. Now for my second constraint, it's an equality constraint, so what should I add?
R1.
I can add R1. So I will have 5x1 minus x2 plus 2x3 plus R1 equal to 2. What is the cost associated with R1? For a slack, it is
Minus M minus
yes,
M.
minus m times r1. Can you think about any other way of doing this problem? Please look at the second constraint. There is one more way. You can divide throughout the second constraint by 2. When you do that, look at your x3. The coefficient of x3 becomes 1, and there is no x3 in the first constraint, so that will give you the second basis vector. This is another way of approach. You can even do like that. Absolutely, you will get the same answer. So here with this, we have all xi greater than equal to 0, all si greater than equal to 0, and all r1 is greater than equal to 0. So my constraints will be xi comma s1 comma r1, all this is greater than equal to 0. So now let us frame the table. How to go about this changes? Initially you will solve as you solve your simplex problem. Then after solving the simplex table, we will see how to incorporate the change. Okay. So first let us solve the simplex table. We will have our CB, we will have YB, we will have XB, I have x1, I have x2, x3, I have an s1, I have an r1, I have a theta. So since r1 is there, I am going to go for big M method. This is s1 is 0. The cost is 5 and 2. So how do I write my cost is 5, 12 and what is this? 4. So here I will have 5, 12 and 4. Here my vectors that are going to enter will be S1 and R1 because S1 corresponds to 1, 0, R1 corresponds to 0, 1. Now look at my first constraint, x1 plus 2, x2, x1 plus 2, x2, and here I have a 5, and the next one is 5 minus 1, 2. So I will have 5 minus 1, 2, and I have a 2 in this position. Right. Now what I need? I need CB. My CB is going to be 0 and minus M. After this, what should I do? I should read my Zj minus Cj. So when I read my Zj minus Cj, how to calculate? So it will be 0 into 1 is 0, minus 5m, minus 5m, minus 5, then 5, what else do I have on top? My first one is x1 plus x2. Please check here. x1 plus 2x2 is less than equal to 5. So here I think I should have a 2. So here it will be 0. Then I will have m minus 12. Then here it is 0 minus 2m. I will have minus 4. Here I am going to have 0. Here minus m plus m. Here also I am going to have 0. So what is the most negative? Most negative is minus 5m minus 5. So x1 enters. So what will be my theta? Yeah? One will be 5. The other will be 2 by 5. So 2 by 5 leaves. So my r1 will leave. My R1 will leave. What is entering? X1. So I will have S1 and X1. Yes, anything I have made wrong? Everybody is getting the same value?
X1.
Yes. So I have an S1 and an X1. My X1 cost is 5. My S1 cost is 0. Now, key row I have to divide by the key element. So I will have 2 by 5, 1, 0, minus 1 by 5. I will have 2 by 5, 0. Then I will have a 1 by 5. 5 minus 2 by 5. So 25 minus 2 by 5. I will have 23 by 5. Check here. Then here I have 2 minus 1 by 5. 10 minus 1 by 5. So I will have a 9 by 5. Check if you are getting this or if you are getting something else also, please tell me. Is it 9 or 21? 2 plus 1 by 5 I believe. 2 plus 1 by 5. 5 into 2 is 10. So what will I have here? 2 plus 1 by 5. So here I think I will have 11 by 5. Then 0 minus 2 by 5. And here it is 1 and minus 1 divided by. So now I need to compute my Zj minus Cj. So calculate your Zj minus Cj. So what happens when you calculate Zj minus Cj? Here it will be 5 minus 5, 0. Here it is going to be minus 1 minus 12, it is minus 13. Then next place it is 10 by 5 minus 4. It is 10 by 5 minus 4. Then last it's going to be 0 here. Here it is going to be 1 plus m. So what happens? I think this is minus 20 minus 10 by 5 minus 2. So x2 enters. Since x2 enters, theta should be non-negative. My s1 leaves. So this becomes our hero. Now compute your iteration. X2 enters. I will have x2. I will have x1. X2 is 12. X1 is 5. So I will go for the next slide. Otherwise, I will not be able to proceed with my Zj minus Cj. So with x2 and x1, compute the next iteration. I think we will be able to fairly finish the problem in this step. After which we will be doing sensitivity analysis. Yes. So we will be having x2 and x1. Check if you are getting this only. If you are getting anything else, please let me know. For this x2 and x1, here my cost is going to be 12. My x1 cost is going to be 5. Then I have to divide the key row by the key element. My key element over here is minus 1 by 5. So please, when I divide this, I have to divide 11. 23 by 11 will be the first entry. So I will have, just check, I will have 23 by 11 and then I will have 0 and then I will have 11 by 5. Then I'm going to have minus 2 by 5. Then I'm going to have 1 and then I'm going to have minus 1 by 5. Then comes the theta value. Right. Then next, what am I going to have? Will I be having, no, I have not computed here. I have to compute for these values. So I will have 23 by 11, 0. I have to divide by 11 by 5, so this value becomes 1 for me. So I will have 23 by 11, 0, 1. After this, what do you get here? Minus 2 by 11. Huh? I'm not sure. Please check for me. I will have minus 2 by 11. Then I will have 5 by 11. And then I think I will have minus 1 divided by 11. Here I'm going to have 9 by 11. I'm going to have 1, 0. I will have 4 by 11. Then I will have 1 by 11 and 2 by. Okay. So now we have to compute our Zj minus Cj. So what happens when you compute your Zj minus Cj? Now what happens here? You are having 5 minus 5 is 0. 12 minus 12 will become 0. Then it will be minus 24 plus 20. Minus 24 plus 20 will give you minus 4 by 11. Please check. Check and tell me. You have a minus 2 by 11 and then you have 23 by 11. 46 minus 46. Then 9 and 4. Check and tell me what you get. Please check this value for me whether it is minus 2 by 11. I have a minus 2 by 5 here. This I have to check. Yes, it is minus 2 by 5 only. Minus 2 by 5 by 11 by 5 is minus 2 by 11 only. And now check and tell me what will happen at this stage? Then I will have 5 by 11 into 23 by 11, 9 into 1 by 11. So all this term will be very positive only for us. And how about the last term? It is minus 23 and plus 18. So minus 5 by 11 plus I will have an m. So m is very big. So this term will also be positive. Come for the second term. The second term alone will be negative for me. Since the second term is negative, x3 enters. So what will I have? Minus 46 plus 36 is minus 10 by 11. Minus 10 by 11, and on top I am going to have minus 10 by 11 minus 4. So minus 10 by 11 minus 4, which is negative. So this enters. Since this enters, my theta should not be negative. So only the second row leaves. So if this is going to be my row which leaves. So my final iteration, I will be having only x2 and I will be having x3. Now, what is the cost associated with our x2 and x3? From the table, x2 is I think 12 and x3 is 4. So 12 and 4. Divide the key row by the key element. So I will have 9 by 4. I will have 11 by 4. 0. I will have a 1 here. 0. I will have 1 by 4 and I will have 2 by 4. Now come for the top. 23 by 11 minus this value. If you do it manually, you will get this answer to be 5 by 2. You please take down the answer. I have verified and I have it in my notebook because sensitivity is the core. This procedure you know. So it is 1001 here, and then over here you will get a half, and here you will have 0. Okay. So with this, if we compute our Zj minus Cj, see what happens to our Zj minus Cj. The first term will give you a 12. The first term will give you 12. Then you will have 0, 0, 7. So you will have a 12. Then it becomes 0. Here also it becomes 0. Here it becomes 7. And then here you have a huge m and plus 2. So everything is positive. So we have come to the end of the problem. So this will give me, just look at what we have. You will have 12 into 5 is 60 by 2. So 30. 4 into 9 by 4 is 9. So the answer here will be 39. So what is my Zj minus Cj? For this value is this entire thing. But however, I want my maximized Z. So my maximized Z will be 12 into the cost that I have got 5 by 2 plus my 4 into the cost that I have got 9 by 4, which gives me 39. Now what we have to change? Till now it is our original problem. We have just solved it. We have used an artificial variable, big M method. We have got the solution. Now what is our concern? We want to change our B matrix. That is, in other words, the requirement vector. So how are we going to change? From 5 by 2 to 7 by 2. Okay, so which are the two positions which constitute your basic variables? It is this particular position because this corresponds to S1 and R1. So since this corresponds to S1 and R1, that is our basis element. So we will consider if the requirement vector is changed. The second case, if the requirement vector is changed, what happens? It is changed to, what it is changed to? I think it is changed to 7 by 2, 7 and 2. From 5 and 2, you are changing to 7 and 2. Now, from the table, I need my B inverse. My B inverse is nothing but this one which I put in the box. That is the value values which are corresponding to the basis elements S1 and R1. So my P inverse is half 0, 1 by 4, 2 by 4. So P inverse is half 0, 1 by 4 and 2 by 4. Now what I need to find XB. What is XB? B inverse B. So this would be half 0, 1 by 4, 2 by 4, this value into the vector 7. So this would give me first row into the first column. So 7 by 2 plus 0 by 2, 7 by 2 plus 0 into 2. Then second row into the column. So it is 7 by 4 plus 2 by 4 into 2, 2 by 4 into 2. So this will give me the vector. What is this? This is the first term becomes 7 by 2. 7 by 4 plus 4 by 4. The value becomes 11 by 4. So you are getting 7 by 4 and 11 by 4. And what does this correspond to? This corresponds to this value x2 and x3 value. This only you are reading, no? What did you read? You read x2 is 5 by 2, x3 is 9 by 4. So what you did is corresponding to this xp value, and xp value is x2 and x3. That's what is there. So this is nothing but by x2 and x3. Now look at this answer. All our x2 and x3 are greater than 0 and x1 is not there, so it is 0. Since it is all are positive, we don't have to worry, and the current solution is a feasible solution. Therefore, our solution remains to be feasible. Once you finish this, you please tell me, I'll give you the discussion. Okay, once you finish this, you please tell me, I will give you the discussion. Should I wait or can I move on? As you say, I will proceed. Can I proceed? Okay, so now what we did, we took the columns corresponding to the basis vector, that is S1 and R1, initial basis. Then we wrote our B inverse. We found out B inverse into the new B value. It is positive. Since all xi greater than equal to 0, since all xi greater than equal to 0, the solution is feasible. There is no problem, there is no change. The solution is feasible. And what happens to my x2 value? My x2 value is now becoming 5 by 2, and my x3 value is becoming, I think, 9 by 4. Therefore, what happens to my maximized z? Hence, maximized z is equal to, what was the objective function that we had here? What was the objective function if I roll up? 5x1 plus 12x2 plus 4x3. 5x1 plus 12x2 plus 4x3. So now how to go about this? So x1 is not there. So it will be 0 into x1. So it will be 0 into 5 plus 12x2. So 12 into 5 by 2 plus 4x3. So 4 into 9 by 4. Now look at this. Here the final value also seems to be, is it the same here? 12 into 5 by 2. Is it 5 here it is 7 by 2 and here it is 11 by 4. So please substitute 7 by 2 and 11 by 4. That is your value. So x1 will become 0. Here it will be 6 into 7 because 12 by 2 is 6 plus I will have 11 by 4 into 4 is 11. 6 sevens are 42. 42 plus 11. The value alone changes, but the solution still remains to be feasible. Hence, this is the new optimal solution. Hence, this is the new optimal solution. Okay, so this is your new optimal solution. Alright. So now we have seen a problem where the feasibility did not change. Next, we have to do one more problem where the feasibility will change. Okay. Yes. Okay, so with that, then we can go for the next changing vector, maybe our CI. Okay, so write down. Second question. Can I proceed with the next question? Yes, can I proceed with the next question? Yes. Consider the LPP. Consider the LPP. Maximize Z. Consider the LPP. Maximize Z equal to 2x1 plus x2 plus 4x3 minus x4. Subject to the conditions. Subject to the conditions x1 plus 2x2 plus x3 subject to the condition x1 plus 2x2 plus x3 minus 3x4 is less than equal to 8. Then second is minus x1, not x1, sorry, minus x2 plus x3 plus 2x4 plus 2x4 is less than equal to 0. Then 2x1 plus 7x2 minus 5x3 minus 10x4 is less than equal to 21 and all xi's are greater than equal to 0. Solve the LPP, solve the LPP and discuss the effect of change and discuss the effect of change of B2. Please look, last time we changed the entire B vector. Here we are changing only one entry of the B vector. B2 to 11. Okay. Now, what I am going to do is again and again we need not waste time doing the simplex problem. I will directly give you the last iteration of this problem. Your homework is to do start from the starting and reach this iteration. Okay. You will reach this iteration I think only in the 4th level. So I will provide the final table and with the final table we will start discussing the effect of B2. Okay. Right. So the final table we are getting on the final iteration. The final iteration, what we get if we solve that problem will be you will have a CB, you will have YB, you will have XB. Then here we are having lot of variables x1, x2, x3, we are having x4, and then we are going to have three slack variables s1, s2, s3. The cost of the slack is 0. From the objective function x1 is 2, x2 is 1, x3 is 4, x4 is minus 1. So in expression, what we will get if we solve. Okay, I have solved, I have it, so I am giving you. The variables would be x2, x1, and I will still have my S3 interface. And the value will be 0. For x1 cost is 2, for x2 it is 1. And under xb, the value we have is 0, 8, 5. Then I have 0, 1, 0, 1. And I have 0, 0. Then minus 1, 3, minus 4. Then minus 2, 1, 2. Then 0, 1, minus 2. Then minus 1, 2, 3. Then we'll have 0, 0, 1. Now with this, what happens to our Zj minus Cj? Right. At this stage, we would have got all positive. That's why we have stopped it. So 8 into 2, 16. 1 into 0, 0. 5 into 0, 0. So it is 16 plus 0, which is 16. Similarly, here you will have 1 into 2, 2. 2 minus 2, value becomes 0. 1 into 1, 1. 1 minus 1, 0. Minus 1 plus 6 is 5. 5 minus 4, value is 1. Minus 2 plus 2, 0. Here value is 1. Then here it is 2. Here it will be 2 into 2 is 4. 4 minus 1, value will be 3. And here it is 5. What will I have? Here it is 0, 0, 0. Everywhere it is 0. So now we have got our answer. Beautifully, we are having maximum z. This is equal to 16. Then what else I have? I have x2 value. x2 value is 0. My x1 value is 8. My x3 and x4 are also 0. They are not there in the table at all. Okay. So this is what I get. Now what I have to do? Now look at the change that I need. I want my basis initially is contributed by S1, S2, S3. So the last 3 rows and 3 columns. This will contribute to my B inverse matrix. So capital B inverse is now equal to 0, minus 1, 0, 1, 2, 0, minus 2, 3, 1. And what is my B vector? I have given my new B vector as, I will have, what will I have? Please come to the original problem which is there. Here when you consider the constraints over here, this implies my B vector to be 8, 0, 21. But what is this 8, 0, 21? This is my B1, B2 and B3. Now what is the question asking you to do? Change the B2. What should I do? I should put B2 equal to 11. So what will happen to my new B? 8, 11, 21. So maybe we can come here. What did I do? Yeah, I did some mistake, I believe. So here my new B will be 8, 11, 21. Let me call this as B star because it is going to be my new B. Next, what I have to do over here, I have to find out XB value. So find XB. What is my XB? My XB is B inverse of small b. So write our B inverse matrix 0, minus 1, 0, 1, 2, 0, then minus 2, 3, 1 into the B vector. What is the B vector? 8, 11, 21. So the first row into this column vector is 8 into 0 is 8 minus 11 plus 0. See, first entry itself is negative, so not feasible. Then next is 1 into 8 is 8. 8 plus 22, 30. Then minus 16 plus 33 will be 17, I think. 17 plus 21, I will have a 34. So this corresponds to x2, x1 and s3. Now what happens? Clearly, I read the value x2 is minus 11, which is strictly less than 0. Therefore, solution is infeasible. A feasible solution has become infeasible. Infeasible solution means what? Problem is not over. We have to continue with the problem. So we have to start solving now. How to start the solution? That is the next query. Therefore, continue. Therefore, continue from the last iteration. Therefore, continue from the last iteration. How to continue here? What should I change? I have to continue from the last iteration. I'll take a new slide, otherwise there will not be space. So, how do I continue from the last iteration? Can anybody tell me what should I change in the last iteration? I have CB, I have YB, I have XB, I have X1, X2, I think we have X3, I have X4, S1, S2, S3. So what should I change? What is the question asking us to change?
X2.
Yes, X2 I should change. That means what should I change in this table? Here I will have 1, 2, 0. Here I will have actually X2, X1 if I am. Yes, total XB column we will change. In that, I will replace my X2 value as minus 11 because he says put V2 as minus 11. So what I should do? V2 we have changed. After changing that, what happens to the XB column? They are having X2 is minus 11, X1 30 and X3 is 38. So this totally we change minus 11, 30, 38. Other than this, all other entries you start retaining as such and solving the problem. So you will have a 0, 1, 0 and then you will have 1, 0, 0. What else you have here? Minus 1, 3, minus 4, then minus 2, I'll have 1, I'll have 2, then 0, 1, minus 2, my S2 will be minus 1, 2, 3, then I have 0, 0, 1, here my cost runs 0, 0, 0, and 2, 1, 4, 2, 1, 4, and minus 1. So now, as usual, with this change in the XB column, which we calculated using this previous formula, that is XB is B inverse B. Okay, it's not transpose, it is inverse. It looks like that, the way I wrote it. It is B inverse B. So take the values from here and put it in the table. So now what is this? Initially it is minus 11 plus 60. So from 60, if you take 11, you will get 49 as the total max result. And then here it is 2 minus 2, 0. 1 minus 1, 0. Minus 1 plus 6, 5 minus 4, 1. Then minus 2 plus 2, 0 plus 1, 1. Then here it is going to be, check if I am correct. I will have double 0, double 1. Then what else will I have here? Yeah, here it will become 0. Then here it will be 2 minus 2. Again it's becoming 0 for me. Is this 0 or something else? Check and tell me. Then the last one is minus 1. Minus 1 plus 4 is 3. I think I will have a 3. And the last entry is also becoming 0. So now what should I do? I have got a double 0. I have a double 1. And then I have minus 2, 3 and 1. So this is what we had. I am just taking this value. Whatever I am having, I am retaining. Now what should I do? What should
The third one, last one, third one, ma'am. There are 2 used. 2, ma'am, instead of 0.
Where? This one?
It's 2 minus 0.
Yes. This one, right? Anything else? Anything else? Check it, tell me. Now what should I do? I don't want this feasible solution. Now if you look, all Zj minus Cj greater than 0. Then what should I do? Actually, I should terminate the process. But should I terminate? No, I want the solution to become feasible. So what I want to leave? I want to throw out x2. Only if I throw out my x2, it will be easy for me to proceed. Otherwise, the solution will be infeasible. So how to do this? What I will do is, since one element is negative, I can apply dual simplex method. Isn't it? If xb is negative, you have to apply that for an infeasible solution. I even asked one more question based on this. So take out. It is infeasible. It is infeasible, and so we use dual simplex method. And so we use dual simplex method. The key row is the row corresponding to x2. The key row is the row corresponding to x2. Therefore, this will become my key row. Am I right? So this will become our key row. Now once I got my key row, I have to find out the key column. How do I find out? My theta is going to be maximum of this Zj minus Cj by a negative number. So look, this is 0, this is 0 ruled out. Here I will have minus 2, here I will have a minus 1. There I am going to have something like minus 3 and so on. So minus 3, minus 2 and all smaller. If I want to choose the most, then it will be minus 1. So I think this will enter for me. Check here. Is this going to enter for me? Or is the next one going to enter? Immediately you should tell, no. Now only you wrote your exam. What will enter? What will enter? X3? X3 or X4? X3 or X4? What is your dual simplex method? How will you choose? You will take the Zj minus Cj value and you will divide by that x2 value, and then you should take the most negative. If you take the most negative, what will happen? Which will enter for you? Here it will be minus 1, here it will be minus half, here it is going to be minus 3. Of this lot, what you want? You want to choose the bigger number, maximum. So minus half is the maximum. So what will enter is going to be x4. If x4 enters, what is going to leave? x2 is going to leave. So now let us check what happens. We will have an x4. We will have an x1. We are going to have still s3. Now see, what is the x4 value? Minus 1, 2, 0. Is it minus 1, 2, 0? X4 is minus 1. Then minus 11 by minus 2 is 11 by 2. Then this becomes 0. Then this will be 1, 0 only. So this becomes minus half. This becomes half. Then this becomes 1 followed by 2 zeros because it is key column. This is 0, so 1 minus 2 directly we can write. Here it is half. Here it becomes 0, so here also we can write 0, 1. Then we have to do the other evaluation. What will I have here? I have a minus 11, and below the minus 11 I am having 30. So what is this? 30 minus 11 by 2. 30 minus 11 by 2 means 60 minus 11 by 2. So it will be 49 by 2. Then 38 minus, so 38 plus 11 by 4. 38 minus 11 by 4. 38 minus 11 by 4 is 4 into 38 minus 11 by 4. You will get a round by 2, then minus 4, minus half, minus 4 and a half, minus 9 by 2, check here, then 2 plus half, 2 minus half, 1 and a half, so it is 3 by 2, then 3, 3 minus 1, value is 2. Check, let me also check if I am correct. I will have minus half, half, 1, half, 5 by 2. And then come for the last one. What is this? This value you please check. This last entry is minus 4 minus 1. Minus 4 minus 1, I think it is minus 5. Then 1 0 0, 0 1 minus 2, yeah, minus 1 2. This come here, minus 1 by 2, 3 by 2, 2. The last is 0 0 1. Check here. Now find out our Zj minus Cj. So 2 into 49 by 2, value is 49, minus 11 by 2. 49 minus 11 by 2 will be here. Here it is 2 minus 2, 0. Then here it is 1 plus half, 1 and a half minus 1, half. Then here it is minus half plus 5, minus half plus 5 is 9 by 2. 9 by 2 minus, this will again give you half. Then here it is minus 1 plus 1, 0. Here it is 2. Then check, here it is minus half plus 3, 2 and a half. I think it is 5 by 2. Then here it is 0. Now look, all our xi's over here are positive. Therefore, we have got a feasible solution. So that's all is what is needed. So 98 minus 11, 87 by 2. Therefore, my maximum z is 87 by 2 under this change, and I have x4 as 11 by 2. I have x4 equal to 11 by 2, and I have x1 equal to 49 by 2. So x4 is 7 by 2, x1 is 49 by 2, and maximum z is 87 by 2. So what is the main what is the main thing in this problem is what happened? Your solution became infeasible. One of your xb column values was negative. So how will you go about a solution? Immediately when that xb column entry becomes negative, what should you do? Go for dual simplex method. Choose the dual simplex method so that you can eradicate that particular value and obtain a feasible solution. Therefore, this is the required solution. These problems will pop up for around 12 marks in your final exam. I think you will be coming to the campus to take or give your final exam. Hopefully, let us hope so. Even if you're not going to come back, you may have a file upload directly for a large question. Okay? Any doubts? In the previous question, the whole vector had to be changed, so we changed. In this question, the second component of the b vector had to be changed, so we changed only p2, and then we obtained our new xb, and then we proceeded by introducing that in the last iteration of the usual problem, given problem, and we obtained the solution. Okay, so people are following?
Yes, ma'am.
Yes. So now we did with B. Now what happens when you change your C vector? What is the C? C is the cost coefficient, which is given as the coefficient of x1, x2, x3 in the objective function. So take down. Changes affecting optimality. Changes affecting optimality. write down. Changes in the coefficient of the objective function. Changes in the coefficient of the objective function may take place. I'm dictating here, I'm not writing. May take place due to a change. It may take place due to a change in cost or profit, due to a change in cost or profit of either basic or non-basic variables, of either basic or non-basic variables. If XP is the optimal basic feasible solution, if XP is the optimal non-basic feasible solution, is the optimal non-basic feasible solution, wait, first we have to discuss basic, then only we can go for this. Okay. If it is the optimal basic feasible solution, then what can you say? Then I can clearly write my XP is nothing but what we used for the previous case, B inverse B. Here, what you say, XP does not contain C. So, XP is independent of C. So, XB is independent of C. So, change in CJ will not affect XB. Therefore, change in CJ will not affect XB. That means what? Yeah, XB is contributing to your feasibility. No. So it will not affect XB. So XB will remain. So XB remains as basic feasible solution. XB remains as a basic feasible solution. So here in this case, you won't have any trouble. Basic feasible solution. Only if it's a non-basic variable, now we have to discuss. So, what happened? The optimal condition. How to check optimality, ma? How to check optimality? What you will tell? Your Zj minus Cj? What, yeah? How to check optimality, yeah? When you stop simplex here, when do you stop the iteration and say sum is of? Ah, that's all. So the optimal condition is that only. The optimal condition Zj minus Cj greater than equal to 0, which is satisfied for all j, which is satisfied for all j, for optimal condition solution, which is satisfied for all j, for optimal solution, which is satisfied for all j, for optimal solution, depends on Cj. Depends on Cj. Therefore, Cj affects optimality. Therefore, change in Cj affects optimality. Therefore, a change in Cj affects optimality condition. These are not probable MCQs. Dash optimality condition. Dash affects feasibility condition. A change in Cj of dash variable affects the optimality condition. Like that. Okay, so these are all probable MCQs. Right. Next. The way,
how much more time do you need?
You have class.
Our teacher who is having exam tomorrow wants to give us some instructions.
Your teacher wants to give you instructions. Just 10 minutes. I will give you the notes and leave you. Another 10 minutes max.
Okay. Thank you.
So that next class we start with the problem.
Okay.
The variation in the price vector C. The variation in the price vector C may be made in the following two ways. The variation in the price vector C may be made in the following two ways. Number one, variation of Cj of the non-basic variable, variation of Cj in the non-basic variable, of the non-basic variable xj in the objective function, variable xj in the objective. So now what should I say? It is non-basic means my Cj will not belong to the basis vector cost. So it is not in CB. So this will change. Cj will now changes to, you will have Cj plus or minus some quantity, say delta Cj. So this is the change, such that by delta Cj, is less than equal to Zj minus Cj. Then, okay, so we change our Cj to Cj plus delta Cj. How we change this? This delta Cj is chosen in such a manner that it is less than or equal to Zj minus Cj. Then the value of the objective function. I am dictating, not writing. Okay. Then the value of the objective function and the optimal solution of the problem remain unchanged. Full stop. The range for Cj to maintain optimality condition is minus infinity less than equal to Cj is less than equal to Cj plus delta Cj. This is the condition. Minus infinity less than equal to Cj less than equal to Cj plus delta Cj. Note, there is no lower bound to delta Cj. Note, there is no lower bound to delta Cj. Okay. Then one more small note. With this, I'll take attendance and leave you. No doing problem. We will start fresh in next class. Variations of Ck of the basic variable xk. Variations of Ck of the basic variable xk in the objective function. So what happens? My ck is actually belonging to, it's not belonging to, it's actually belonging to the basis variable. So it belongs to the cost vector of the basis variable. Therefore, ck belongs to cb will now change to ck plus delta ck. Therefore, the range to maintain optimality, what to do, yeah? What will be the range to maintain optimality? This is given by maximize Aij. Aij is coefficient of the A matrix, coefficient matrix of the constraints. Aij greater than 0 minus Zj minus Cj divided by Akj, which is less than equal to my delta Ck, which is again less than or equal to, minimum, whatever I have, my Aij less than 0, there it should be positive, here it should be negative, of the same condition, minus of Zj minus Cj divided by my Akj. Okay, so this condition we have to work up, because when we do the problem we have to verify with this condition only. So this is the required condition. Now only one line with this I close. If there is no Akj greater than 0, if there is no Akj, if no Akj is greater than 0, there is no lower bound. There is no lower bound. Okay. There is no lower bound to delta Ck. Similarly, if no Akj is less than 0, then there is no upper bound, then there is no upper bound to delta A. Okay? The value of the objective function, will be improved by the value of the objective function will be improved by what quantity? It will be improved by xpk delta cbk into delta cb. That is my z star, that is the new solution that I get, will be z plus this xpk into delta cbk. Now if you just look at this, it will make no sense for you. In the next class I will do a problem when there is an akj greater than 0, what happens? When there is no akj greater than 0, what happens? Okay, with that we will be concluding in the next class. So now I will take attendance and leave you for instructions in your next subject. Okay, so we will take attendance. Register number 1 is there?
Yes, ma'am.
2 is there?
Ma'am, chat box.
Chat box. Oh, okay, I will change the screen. Where is our grid view? Grid view not working. Okay. 2 is there in chat box. Then 3,
Present, ma'am.
4,
Hold on, ma'am.
5,